In the previous video, we used Euclid's algorithm to find the greatest common divisor of these two rather large numbers, 12,378 and 3,054. So in doing so, we continually used the division algorithm, which basically means break the two numbers into A equals Q times B plus R, where this is A and B. And we iterated on this several times. In the second step, this became A and this became B down here. Then this became A and this became B in the next step. And then this became A and this became B in the next step, and so on. And we discovered that the greatest common divisor of these two numbers is 6. Well, it turns out that when you find the greatest common divisor of two numbers, there is some linear combination of these two numbers that will give you 6. Remember what a linear combination is. It means there's an integer we could multiply this one by, say, x, an integer we could multiply this one by, say, y, and we could add 12,378 times x to 3,054y and get the number 6. So in this video, we're going to show how we can do this. And we're basically going to be using all of this information, but we're going to be working backwards. We're going to start with this number 6. And from just this one equation, we know 6 is equal to 24 minus 1 times 18. And then we will take that equation and we'll replace the 18 with, go to the previous equation, 18 is equal to 138 minus 5 times 24. And we'll do some simplifying. Then we'll end up taking the 24 in the new equation and replace the 24 with 162 minus 1 times 138, and so on, until we get up to the top. And eventually, we will have 6 equaling this number times some integer x plus this number times some integer y. So let's start that. Now we need this work, so I'm just going to slide the paper over a little bit. And let's read what we've got here. By fact number 6 that we looked at a few videos ago, we know that 6 divides this and 6 divides this, means that 6 goes into or divides any linear combination of these two numbers, which is written right here. 6 will divide 12,378 times x plus 3,054 times y for every single integer x and y. What we're going to look for now, as I mentioned earlier, is we're going to find a particular value of x and y such that this right-hand side here will actually equal the number 6. So we're going to try to solve this equation. We're going to find an integer x and an integer y such that we'll get a 6 as the result. So we're going to use our previous work, as I mentioned. I'll keep it right over here. And we're going to work backwards. So we're going to start, as I mentioned, with the equation 6 equals, solve this equation for 6. 6 is going to be 24 minus 1 times 18. Just like that. So now for the second line of this, we're going to say 24 minus, but we're going to replace the number 18 with what this equation gives us. If we solve this equation for 18, we would get 138 minus 5 times 24. Like so. Okay, so from this point, at every other line we get to, we're going to have to do some factoring and simplifying. So the numbers that we want to kind of group together are the 24s and the 138s in this case. So this is going to be equal to, well, how many 24s do I have total in this? We're going to have to think a step or two ahead. I've got 124 right here. And how many do I have here? It looks like I have negative 5 times 24, but there's a negative 1 in front of it. So that's really a positive 5 times 24. So if I simplify this, I actually have 6 times 24. And then how many 138s do I have? 1. I'm sorry, a negative 1. So I will, for now, call this minus 138. I guess I left off the minus 1 times 138, but that's not a big deal. Okay, so now we've got these. We're going to go back to this next equation. So far we know 6 is equal to 6 times 24 minus 138. Well, now the 24 is what we're going to solve for. We're going to go backwards one equation and get here. 24 is 162 minus 1 times 138. All right, so I'm going to replace the 24 with 162 minus 1 times 138 in parentheses, and then I'm just going to have another minus 138. So all I did is replace this 38 right here with 162 minus 1 times 138. That substitution came from this equation right here. 24, I hope I said that correctly. I replaced this 24 right here with 162 minus 1 times 138, which came from this equation. Now we're going to go back up one. Oh, well, first let me do some simplifying. So we've got 162s and we've got 138s that we want to group together. I have a total of how many 162s? Well, if we distribute through, it would be 6 times 162. Now, how many 138s do I have? I've got negative 1 of them here. This would be like saying plus negative 1 times 138. And this, if I distribute the 6 through, would give me a negative 6 times 138. Negative 6 of them minus another one gives me minus 7 times 138. Okay, so now we've got 2 more equations to back into here. Now I'm going to solve for this remainder. 138 is equal to 3054 minus 18 times 162. So I'm going to replace this 138. 6 times 162. And then I'm going to replace the 138 with 3054 minus 8 times 162. .3054 minus 18 times 162. Okay, so now I've got to get the 3054s and the 162s gathered together. So I'm going to count up how many 162s I have. I've got 6 of them here, 6 times 162. And over here, it looks like I have negative 18, but that negative 18 is multiplied by negative 7 as I distribute it through. So 7 times 18 would be 70 and 56. That'd be 126. Plus 6 would be 132. That's how many 162s I have. And then it looks like I just have minus 7 3054s. Minus 7 times 3054. Okay, so now we've got 132 times 162, and now I'm going to have to replace this 162 because we're going back. We only have one more equation to go to. We're all the way at the top. This remainder is 162. 162 is equal to 12,378 minus 4 times 3054. So let's replace 162 All right, so 132 times, instead of 162, I'm going to write 12,378. Oops, sorry about that. I went off the screen there. 12,378, and then minus 4 times 3054. So we just replaced 162 with this expression, and that's because of this equation here. 162 is equal to this minus this. All right, so then we have minus 7 times 3054. And we'll factor this once again, or kind of simplify it together. And I'm going to get, as far as 12,378, I'm going to have 132 times 12,378. And then I'm going to have plus something or minus something times 3054. Let's see how many that is. I have 132 times negative 4. That's how many of these I have, 3054. So 132 would be 264, 528. That'd be negative 528. And then minus 7 would be minus 535. And essentially we are done. We were looking for a linear combination of these two numbers, 12,378 and 3054, that would give us the number 6. So we found the x and the y. 132 will be the x. Negative 535 will be the y. So what we did here, I'll just kind of summarize it in one line. The greatest common divisor of 12,378 and 3054, which we know is 6, is equal to 12,378, I'll just write x for the time being, plus 3054y. And we showed that the x value that works is 132, and y is negative 535. And you will find that that always works. When you take the greatest common divisor of two numbers, that greatest common divisor can be represented as a linear combination of those two numbers. And maybe I'll write that down as a theorem, generalizing what we just did. The theorem would say this: for two numbers a and b that are integers, and I'll just go ahead and specify not both 0, there exist two numbers which I will call m and n in the set of integers, such that the greatest common divisor of a and b is equal to am plus bn. So once again, all we're saying is that if you take the greatest common divisor of two numbers, there's a way you can find a linear combination of the two numbers that will actually equal the greatest common divisor. So in our example, this number here was 6, corresponding to this up here. Maybe I could have made a note here that this for us was the number 6.